And we're on level 5 of graphing trig functions, and at this point you can see we've got all values. And what I mean is in the generic form of the trig equation, we got y equals a, let's see, this time we have a cosine b x minus c plus d. Now, let's just kind of focus in on what those mean. Okay, the a is the amplitude. A is amplitude. Now the b value isn't the period, but we use it to find the period. So 2 pi over b is the period. And I'm going to use a different color for that. Let's go with yellow. Okay. What about the c value? The c value is the horizontal shift. So that tells us if we're going to the right or to the left. And the d value, also known as the k value, I've seen in the notes here that they use h and k instead of c and d, and that's not a problem. The d is the vertical shift. So if you see k being the vertical shift, that's fine as well. So that's where we're going along the y-axis. Alright, so let's get some colors here. Let's see, and that'll be D. Okay. So we have to find our A, B, C, D values first. So obviously, I can go through here and pick those out pretty easily. My A value is going to be 12. So as I tackle this problem, I know that A is 12. I know that B is 3/2. Okay, C. In this case, C is moving 2 pi over 3 to the left. So the C value, 2 pi over 3 to the left. This will help when I'm making the graph here, when I'm building the graph. And then finally the D value, the vertical shift, we can plainly see here in pink, it is going to be -16. So we're going to be moving 16 down. Okay. Now before we start doing any graphing, let's find the period. And to find the period, remember the period is 2 pi over b. Now we've already said here that the b value, we know what it is. The b value is 3/2. So to find the period, all I have to do is take 2 pi over 3/2. That might be a little intimidating, but just think of it as a division of fractions. So we have 2 pi over 1 times the reciprocal of the denominator, which is going to be 2/3. And then I will just multiply those, and that's going to be 4 pi over 3. So the period is 4 pi over 3. Now what does that do for us? Well, let's go and get the parent function. Let's just graph y equals cosine x right now real quickly. Alright, so y equals cosine x. So we know at 0, right, cosine is going to be 1. So I'll just put like a little thing there. Okay. Now cosine at pi over 2, which would be 90 degrees, would be at 0. At pi, probably right about there, pi, it's going to be at -1, so it'd be like right about here. Doing these by hand, so it might not look exact. Then we've got the next quadrantal angle, which is 3 pi over 2. And where is it at 3 pi over 2? Well, if you're having trouble thinking about it, that would be the one right here. Cosine is the x value. What's the x value there? It's 0 again. So we put that there. And then once we're back around the circle at 2 pi, which would be right here, cosine is back to 1. So if we did not translate the function, if we didn't do any other kinds of transformations with the function, that's what it would look like. Clearly, though, we are doing quite a bit of transformations with the function. So it's not going to end up looking like this. So that brings us to step number 4 here, shift, slide, and scale. So I'm just going to draw another scale here, or another coordinate plane like I did here for part 3. Now before I label it, I'm going to look at my horizontal shift, which is right there. That's telling me that I'm moving 2 pi over 3 left, because we're adding 2 pi over 3. So what's 0 here will be negative 2 pi 3 over here. Negative 2 pi over 3. Now what's the period? How long will it take to complete one full cycle, just like we see here? Well, we said the period is 4 pi over 3. So we're going to do negative 2 pi over 3 plus 4 pi over 3. That's pretty simple, right? That's just going to be 2 pi over 3. So it'll complete one full cycle from negative 2 pi over 3 to 2 pi over 3. Now we just fill in what's in between these, which would be 0. So there's going to be a point there. Fill in a point between negative 2 pi over 3 and 0. Well, that would be negative pi over 3. Fill in a point between 0 and 2 pi over 3. That's going to be pi over 3. And see, now it's going to get, I shouldn't say tricky, but I'm going to draw another one here real quick. Now, before we actually plot these, we have to consider the midline. Okay, the midline, figure the graph, remember when we did the graph function, the midline here was 0. Well, that means midline now is going to be right here at y equals negative 16. Okay. Now, let's go down here and draw that. Let's do this right here. Okay. Probably have to extend this a little bit. That's not a problem. Okay. Alright. So now we've got the midline here at negative 16. Okay. And where's the maximum of the graph going to be? Well, if we are multiplying by 12, as we can see here from the amplitude, that means we're going to add 12 to negative 16. And that would be, I guess right about here at negative 4. That's going to be the maximum. And then we're going to subtract from negative 16, 12, and that's going to be the minimum at negative 28. Now we've also shifted. So we know that negative 2 pi over 3, that's going to start at, we're at cosine. So it's going to be starting at the maximum, which is going to be here at negative 4. Now we're plotting the points. Okay, at negative pi over 3, it's going to be coming down to negative 16. 0, it'll come down to negative 28. Pi over 3, it'll be back at the midline. And then at 2 pi over 3, it's going to be back at the maximum of negative 4. So it'll look something like this. Alright, now we have to go and graph this, which we have to choose our x-axis label and our y-axis label a little carefully. So let's go do that. So I have to get down to negative 28, so my x-axis label is probably going to have to be 4, so I can get down to negative 28. I don't think if I did 2 would be enough. And then the axis label. Well, we wanted 2 pi over 3 for the starting point and the end point. So let's do that. Let's do 2 pi. Oops. It didn't give me the option of using division there. Okay, 2 pi over 3. And let's get that done. All right, we can fit it in there. So 2 pi over 3, let's go with, that'll be 1 pi over 3, 2 pi over 3. All right, now we can begin the process of graphing those points. So remember, we had negative 2 pi over 3, which is, that's pi over 3. That's 0. Negative pi over 3. Negative pi over 3. And 2 pi over 3 right there. Okay, so that was at the maximum, which we said was negative 4, I believe. The next point is at the midline, which is 16. The next point, 0, is at the minimum, which was 28. Pi over 3, that was right here at negative 16 again. And then 2 pi over 3 right here at negative 4. I've got my graph here, and I'm going to submit my answer. And I'm going to be right. And yeah, when they take you through the answer, they will use H and K. That's the same thing. Okay, they've given us a new problem. Let's go ahead and tackle this one. So I'd like you to try this on your own, and then when you're ready, you can unpause, and I'll unveil my solution a little bit at a time. Okay, the first thing I do is just simply identify the A, B, C, and D values. A, the amplitude is 8, so that's going to be 8 up from the midline, 8 down from the midline. Going to be the maximum and the minimum, respectively. Then we've got the B value, which is pi over 4. The C value is telling us we're going to be moving and shifting that 6 units to the left. And the D says we're going to be shifting 16 units up. Okay, the next thing I'm going to do is find the period. I've set it up here, so if you want to get that before I reveal the answer, that'd be swell. Alright, so the period is 8. I got that by taking 2 pi and dividing it by pi over 4, which is essentially 2 pi times 4 over 1. Pi's cancel out and we get 8. Then I sketch out the parent function, y equals cosine x, just so I can get the feel for the shape of this graph. I realize that I'm going to be shifting it 6 units to the left because of that. And then the period is 8, so negative 6 plus 8 equals 2. So it'll complete one full cycle from negative 6 to positive 2. Right in the middle of those is going to be negative 2. The middle of these will be negative 4. And then here will be 0. So then it's going to be the maximum here. Come down, minimum here. Come back down to the midline, and then maximum again. Now I'm almost there, folks. All I've got to do is find the new midline, which is going to be a positive 16. So everything's going to be coming up 16. So the midline here is at 0. That means the midline will be at 16. So I'm going to draw one more graph here. So the midline is at y equals 16. Remember, the amplitude is 8. So that means I'm going to be coming up to 24, y equals 24, and going down to 16 minus 8, which would be 8. And then we're going to just have the same pattern. We're going to be starting out negative 6 at the maximum, which is now at 24. Negative 4, it's going to be at the midline. Negative 2, it's going to be at the minimum of 8. 0, that's going to be at the midline, and 2 is going to be at the maximum. So it'll look something like this, with 2 maximum points at y equals 24, 1 minimum point at negative 8. Okay, then again, we've got the scale, which is, I think, can be the toughest part of it. We need to get all the way up to 24. I don't think 2 is going to do it, so I'm going to put a 4 in here. And then we're not using pi this time as an axis label. We'll use, let's see, let's just go with 2. And done. Okay. So let's bring that here. And let's make, just to give ourselves a little room, let's make every scale, or 1/2 will be the scale for the whole thing, so we have a little bit more room. Actually, I don't know if we'll be, because we need to get to negative 6, so let's just move that down there. Okay. So negative 6 would be 1, 2, 4, 5, 6 right here. That's going to be at the maximum of 24. Okay. The next one, which would be -4. All right, we put that one at the midline of 16. -1 here, or -2, sorry, that would be at the minimum of 8. 0 would be back at the midline, and 2 would be back at the maximum. And I will submit my answer, and I'll get it right. Okay. All right, so those are a couple examples of graphing trig functions level 5.